Alright, welcome back, guys. So this next example will be finding another weighted mean. Okay, this is very similar to the last one. It says your grades from last semester are in the table, and the grading system assigns points as follows. And you guys probably know this. There's 4 points associated with an A, 3 with a B, 2 with a C, 1 with a D, and then no points associated with an F. And so this is actually how you determine or calculate your grade point average. Okay, in case you ever wanted to do that, this is how it's done. So the data values in this case are the actual numerical values that correspond to each of these letter grades. Okay, and then the weights are the actual number of credit hours for each of these courses. So from above, a C counts as 2 points, a D counts as 1 point, an A is 4, C is 2 again, and a B is 3. Okay, and then I'm going to input these corresponding weights, which is basically the duration of the course, or the length. Well, not really the duration, but okay, and then we're going to find the products of each data value and its corresponding weight. So 2 times 3 is 6. We get 8, 1, 7, 4, and 9. Okay, so now what I want to do is I want to find the sum of the products of data values and their corresponding weights. Okay, so I just sum up this column right here. We may be able to do this in our head. So 9 and 4, that's 13, and 7 would be 20, 21, 29, and then 35. Okay, so the sum of those products is 35. Now we're going to see what the sum of the weights is. So we would sum this column. So 3, 4, 1, that's 8. This would be 11, 12, 13, 14, 15, 16. Okay, and so therefore the grade point average, or X bar in this case, actually I'm going to write the grade point average. Okay, it's going to be the sum of those products divided by the sum of the weights. So this will end up being 35 divided by 16. And if we look at this in the calculator, we get, typically you'll round these to the hundredths place, or the 2 decimal places. So this would be 2.19. 2.19. So that would be the GPA for this particular student. And that, you know, as you guys know, that's not particularly stellar, but it is passing. Okay. C's get degrees, as they say, or at least that's what my students tell me. Alright, so 2.19. Alright, so we've looked at a couple examples on how to find the weighted mean. Okay, so now we're going to look at an example of how to find the mean for data that's grouped. Okay, so like if you had a frequency distribution and you knew how many data values were in each class, but you didn't actually know the data values, you can still find an estimate for the mean. And so this is the formula that we're going to be using. And if you look at this, this looks very similar to the weighted mean, or the weighted mean formula. You've got the sum of the products. So the products in this case are going to be comprised of a midpoint and a frequency. Okay, so the midpoint comes from that particular class, and the frequency will be the number of data values that are in that class. So this is really the same thing, guys. It's the data value times its corresponding or respective weight, and then your denominator is going to be the sum of those frequencies. Okay. So I'm not working this one out for you. We'll just kind of read over it. So your first step in doing one like this is to find the midpoint of each class, and you guys know how to do that. It's just the lower plus the upper limit divided by 2. And then you're going to find the sum of the products of the midpoint and frequencies. Okay, so if these are the midpoints right here, and these are the respective frequencies in each of those classes, you would multiply these together. Okay, and then you would sum all those products up. And then you would find the sum of the frequencies, so you'd be adding up this last column. And then lastly, you would be dividing, and that would give you an estimate for the average, or for the mean, from data that's grouped. Okay. All right, so here's an example. So we don't actually see the frequency distribution. But let's say these are the midpoints from the 4 different classes, and these are the corresponding frequencies in each of those classes. So the first thing we would do is find those products. Okay? So just like we did with the weighted mean, just multiply these, and then you're going to find the sum of these products, and that's what we get right here. Okay, if you were to add up this column, you're going to get 756.5, and then you find the sum of the frequencies, so you sum this column, and you're going to get 31, and your last step is just to divide. Okay, 756.5 divided by n. The sum of the frequencies is actually n. It's the number of data values, right? And so in this case, we'd end up getting 24.403. And that would be the estimated average. Now, is that the actual average of the data set? Probably not. Okay, because we don't actually know what the data is. We just know how much data falls in each class. So we use the midpoint as kind of an estimator, an average of the data values that are in each class. So that's kind of how this works. So this is going to be an estimate. You would need to know the actual data to find the true mean. Okay. I guess this one's going to be a rather short video. Probably should have just kept on going in that last one. All right, well, the last thing we're going to talk about are the shapes of distributions, and we'll talk about this more in detail as the semester progresses. But guys, when you make a frequency distribution and then you make a histogram that corresponds to that, and it has different bars like we saw up here, the heights of these bars and where these bars are, that is a visual that is a visual of how the data is distributed, just like a dot plot or stem and leaf diagram. Okay, so you can see most of the data is over here, and of course there is an outlier. So anyway, when you do construct some sort of graphical illustration of a data distribution, it's going to look differently depending on the data, okay, and how it's distributed. So there's some different types of distributions that we're going to see in this course. So a frequency distribution is symmetric when a vertical line can be drawn through the middle of the graph of the distribution and resulting halves are approximately mirror images. Okay, so I've got an example down here for you. This would be, we don't know what this histogram actually represents, what kind of data, it doesn't say, but this would be an example of a symmetric distribution. So we had a frequency distribution, we made a histogram from that, and this is what it looks like. And so you can see that with a symmetric distribution, typically the mean, the median, and the mode all will be around the center of the distribution. Okay, and we talk that symmetric distribution, guys, occurs a lot, and we're going to talk about it later on. And then we say a frequency distribution is uniform when all entries or classes have equal or approximately equal frequencies. Okay, And a uniform distribution is actually symmetric. So I have an example down here. Okay. This might represent, the last digit in a social security number for a whole bunch of people. And you would expect a random distribution of digits there, and that's where you get a uniform distribution like this. So it is actually symmetric, and consequently the mean and the median are going to be close to the center. Okay. Now it won't really have a mode because it's uniform. Okay. You can see here each class has the same exact frequency, so there's not one class that has a higher frequency than another. Now this is a perfectly uniform distribution. In the real world, things are not perfect lots of times, right? So, but anyway, and then the last type we're going to talk about or see is called a skewed distribution. So that's when your distribution is going to have what we refer to as a tail. Okay, and that tail is typically caused by there being less and less data on one side and the majority of the data on another side. Okay, so here's a couple examples down here. This is a skewed distribution because it has a tail, right? You could say, well, they both have tails, right? One on the right and one on the left, but the one on the left is longer. So this is what we refer to as a left-tailed distribution. And then this other one, it has two tails, but the one on the right is more prominent. Okay, so we would refer to this as a right-tailed distribution. All right, and now let me zoom in here just a little bit. So with a symmetric and a uniform distribution, basically because they're both symmetric distributions, the mean, median, and mode are all going to be real close together, if not the same. But with these skewed distributions, that's not the case. Typically they're skewed because of outliers. So this left-tailed distribution, there's probably some outliers over here. And those outliers way out here pull that mean over to the left. Okay? The median and the mode would typically still stay in the middle. But let's contrast this one with the next one, in which we have outliers to the right. So we have a right-tailed distribution. That pulls the median over to the right. Okay? All right. So every data set is going to be distributed differently. Okay? And these are some of the most common distributions that we'll see throughout this course. All right. Well, like I said, this ended up being a shorter video, so I'll see you in 2.4, in which we're going to talk about how to quantify how spread out the data is. Okay. So anyway.